So this is just going to be a quick video where we look at some example questions of indices or powers, okay? And first, I've just written out this big massive list of powers. The reason I did that is because these numbers are really helpful to know. So you don't have to learn each one off, but if you can at least recognize that 4, 8, 16, 32, 64, etc., 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 that they're all powers of something, then it's really helpful for questions like this that you can spot it straight away and you can turn it into one of these powers and simplify it a lot easier. So I'd recommend looking through those, just kind of getting to know them, because they'll come up again and again in indices. So the more you practice, the more you get to know them as well, but just to have a brief look at them now. Anyway, I'll just continue with this question. So the questions are going to look something like this. Write 64 to the power of minus 4 over 3 in the form 1 over n. Okay, so yeah, I guess I'll just get started. We have to simplify this here until it looks like this, 1 over and just a number here. So we'll take it one step at a time. So the first thing I'm going to do, I'll just write it out again, 64 to the power of minus 4 over 3. The first thing I'm going to do is get rid of the minus. So we know that that's going to turn into 1 over 64 to the power of 4 over 3. So remember, the minus just makes it 1 over. Yeah? So next, I'm going to change this on the bottom, so 64 to the power of 4 over 3. I'm going to use the last rule we looked at. So I'll do this in yellow. It's going to be, so again, it's going to be 1 over. So remember, the number on the bottom goes on the outside, so it's going to be the cubed root of 64. So the number on the bottom goes before the root, and then this whole thing is going to be to the power of 4, because that's what this number here in the fraction does. Yeah? So then I'll go down, 1 over, so the cubed root of 64, if we go up, is 4, because 4 to the power of 3 is equal to 64. So 4, and again, that's why it's so handy to know those. And then 4 to the power of 4, again, I'll go up, is 256. So you don't really need to know them after that, because the numbers get too big to be kind of useful. Nobody's going to learn them off, but just those ones, they do come up a lot. So the final answer is going to be 1 over 256. So n is equal to 256 anyway, in this case. Does that make sense? So it may look quite complicated at the start, but if you do one rule at a time, like changing 64 to the power of minus 4 over 3 to 1 over 64 to the power of 4 over 3, so it actually takes longer to say than it does to do. It's just doing the minus rule, so that's in the log tables, and then doing this one again is in your tables book, and then getting the cubed root of 64 isn't too hard, and getting 4 to the power of 4 isn't too hard. So individually they're not that hard, but when you look at it kind of overall, it might seem daunting. Again, just break it up into little bits. So we're going to do one more example down here. So here's the question there, just quickly wrote it out. So they're asking us to simplify, oh no wait, sorry, I will just correct that. It's a to the, so simplify a root a all cubed divided by a to the power of 4. Okay, so that 4 is a little bit big. So what they want us to do is just to write that in the form of one number, so it's just going to be a to the power of something. Yeah, so there shouldn't be all the other bits. And again, this is just about simplifying it bit by bit. The best way is to change everything to index form or to indices, and then you can use the rules. So I'll go ahead and I'll start this. I'll go red. And actually as well, you guys should pause this, try it yourselves, and then you can check it. So again, you'll learn a lot better if you actually are actively doing things while you're watching the videos. So anyway, I'm going to do, first I'm going to change this and this to power form. So it's going to be 8 to the power of 1. So 8 to the power of 1 is just itself, yeah. So you can change a to 8 to the power of 1, that's the same thing. Multiplied by, so dot 8 to the power of a half. And that's cubed, and that's over 8 to the power of 4, yeah. So then I'm going to do what's inside the brackets here. It's 8 to the power of 1 dot 8 to the power of a half. So that's going to be the first rule of indices. So that's going to be 8 to the power of 1 plus a half, all cubed, and that's over 8 to the power of 4. Okay, 8 to the power of 1 plus a half, that's going to be 8 to the power of 3 over 2, cubed, and that's over 8 to the power of 4. Now the top rule here, 8 to the power of 3 over 2 cubed, that's going to be 8 to the power of 3 over 2 times 3. That's over 8 to the power of 4. So remember, that's the third rule. I'm going to scroll down a little bit and I'll change colour again. So 8 to the power of 3 over 2 times 3. That's going to be 8 to the power of 9 over 2 divided by a to the power of 4. And now this is the second rule. It's going to be a to the power of 9 over 2 minus 4. So when they're dividing, you take them away from each other. And that should say 9, not 8. Yeah. And not 8. And then a to the power of 9 over 2 minus 4 is just equal to a to the power of a half, or the square root of a. So whichever one they want the answer at. So is that okay? So I'm just trying to show that doing each individual question isn't too hard, even though the whole thing looks kind of quite hard at the start. But if you just break it up into each individual little rule, step by step, it shouldn't be too bad. So they're the kind of questions you're going to get on indices, and we're going to look at some more harder examples, just some harder examples next.